Hello everyone, welcome back to my channel. Today let's go over a medium question that I solved over half a year ago. So this one's called find the minimum and maximum number of nodes between critical points. So a critical point in a linked list is defined as either a local max or local min. Local max is a node that has a value greater than the previous in the next node. Okay, pretty simple. Local min is smaller than the previous in the next node. So for example, 3 would have to be smaller than 5 and 1 to be classified as one. So a node, if there exists both the previous and the next node, so turn an array containing the min distance and max distance, min distance between any two distance critical points, the maximum. Okay. So fewer than two critical points, return -1, -1. Okay, this one obviously is because there's not even 3 nodes. So let's go ahead and try to turn this linked list into an array. So integer array, while head, cur.append, head.val, using this attribute, head equals head.next. So just like iterating over the linked list using the pointers. Let's print current. And like we said, if length of current is less than 3, we can just return -1, -1 right away. Otherwise, for I in range 1 to length of cur -1, because we want to go from this to this, comparing the last and the next, the last and the next, the last and the next. This doesn't have a next, this doesn't have a last, right? So in that case, let's call these bad nodes because they have there are critical points that are variable names. So if cur of I -1 is less than cur of I, and cur of I plus 1 is less than cur of I, then it's a maximum point. So cp.append cur of I. If cur of I -1 is bigger than this one, and the right one is also bigger than the middle one, then same thing. Let's print cp. Okay, so 1 and 3, minimum distance between any two critical points, distinct critical points. So local maxima, local minimum. Why is this minimum distance third load? Yep. Minimum distance between the 5th and the 6th node. Okay, so we care about the index, I guess, is what they're saying. I think. Okay, cool. So they are. So it looks like 5 minus 4 is 1 that's smaller than 2 minus or 4 minus 2. 3 is 5 minus 2, which is smaller than 5 minus 4 or 4 minus 2. Okay, so we want the min and the max distance. So say for I in range length cp, for j in range length cp, say small, big. Small is trying to be as small as possible, so nothing is smaller than, everything has to be smaller than infinity, vice versa for big. Small equals to min of small, cp of I minus cp of j, I plus 1 because we don't want to cross, you don't want to compare the same element with itself, that'd be cheating. max of B, CP of I minus CP of J. Let's do absolute values. Let's print small and big. Okay, cool. And now we just want to return an integer list, so we don't have to turn it back into a linked list. So just return small and big, it seems. And you may get timeout because this is n squared. Oh, okay. So if s is equal to infinity and b is equal to negative infinity, meaning they didn't change from the beginning, then return -1, -1. Let's look at the constraints. Yep, time limit exceeded. Okay. Okay. I guess we could just keep track of it right now like this. So okay. So if CP, then S equals min of S and absolute value of CP -1 minus I, right? If CP, same thing. CP of I, or just I, not CP of I, because we're just looking for the index. Okay, nope. Okay. Let's get this back. So perhaps what we can do is just run a binary search. cp.sort. And then for each element, just run a binary search and find the closest element. For C and CP, let's say B equals bisect left inside of CP, C. Let's print B and CP. So we got index 0. Obviously that's not what we want. So index 1. So if B -1 is bigger than or equal to 0, print B -1 CP. If B +1 is less than length of CP, print B +1 CP. Okay, so zero. Not gonna lie, this is actually kind of hard. So how to overcome, so for 2, the closest one is, okay, let's print CP, B -1, and also C. CP, B +1, and C, so the current element. 4 and 2, 2 and 4. Okay, cool. So now we can say S equals to min of S, absolute value of C minus CP of B -1, because we don't want the same element, right? If we bisected here and we're looking at 4, obviously you can't cheat with 0. And then we do this as well. And this as well. Turn S and B. So hopefully that works out. Okay, it doesn't. Okay. Oh, we're not looking at all the elements. Okay. Well, the maximum would just be the B would just be max of CP or CP -1 minus CP of 0, right? No? Okay. Equals max of B and this, but also this has to come back. No? Yeah, that's right. I don't know why. CP of -1 minus this absolute value. Print B. Yeah, that's 3. Why is this not working? What? Okay, maybe we could just try for I in range 1, length of CP. S equals min of S, absolute value of CPI, minus CP of I minus 1. Print S. Okay, S seems to be right. B equals to max of B, absolute value of CPI, minus CP of I minus 1. So that's a tricky thing with B is you have to compare every element and find the maximum. Max of B, absolute value of CPI, current 1 minus CP of 0, and then minus 1 as well, hopefully. No? Oh, return S and B, because we're looking at both ends, right? Oh, okay. Well, if S is equal to float of infinity and B is equal to float of negative infinity, because then return -1, -1. Oh, wow, cool. Wow, okay, nice. Wow, very happy because I haven't solved this in a while. It took a lot of work, but finally did it. So yeah, hopefully this part wasn't too confusing. We just take the current element, look at both ends, because the difference can't be bigger than either this side or this end from the current element. That's why this line's there. So other than that, it's pretty straightforward. Thank you for watching and stay tuned for more.